Chapter 1: Introduction and Basic Principles from the textbook Additive Manufacturing Technologies, written by Gibson and et al. The topics to be covered in this chapter are: what is additive manufacturing, what are AM parts used for, the generic AM process, why use the term additive manufacturing, the benefits of AM, distinction between AM and conventional manufacturing, as well as example AM parts and other related technologies. This also includes several subtopics in it. The first topic is what is additive manufacturing. Additive manufacturing or 3D printing has evolved from the term rapid prototyping. The term prototyping is there from the ages, which does mean to create physical models that resembles as final product. Rapid prototyping technology decreases the prototyping time and enables this process of creating them quickly. Hence, it has also been termed as rapid prototyping. The RP models helps to create final models easily, or which minimizes the time and effort in creating of final models. The major use of these prototype models are to get feedback from clients or stakeholders during the development of a product. RP has been widely used to create the physical models directly from the digital data. The current textbook is about the next technologies that are creating physical models, which are being used for many other purposes apart from prototyping. The current users of this technology felt that the term RP is inappropriate for the current capabilities of this technology. The advancements in this technology made these models resemble similar to final models rather than prototypes. This technology uses additive approach to build the models. Technical committee within ASTM felt that additive manufacturing is appropriate term compared to rapid prototyping for this technology. This has been agreed by most of the standard bodies worldwide and commonly referred as AM. The basic principle of AM technology is to create physical models using three-dimensional computer-aided design, 3D CAD data directly. This doesn't need any process planning even for complex models. Other manufacturing process requires huge amount of data like what kind of tools, fixtures to be used, or series of manufacturing operations to be carried out to obtain the final product. But in case of AM model, it requires very minimal amount of data like surface or dimensional information and with which material and machine to be used for manufacturing. The key for AM model is by adding material layer by layer in thin cross sections, which has been derived from original CAD data. By adding up of all these layers, a physical model gets formed. In this, layer thickness plays a crucial role in case of approximation or representation of 3D CAD data as shown in the figure. As the layer thickness is thinner, the model looks closer to the original data and vice versa. All AM machines uses the same approach of layer by layer, but difference will be material, the way of creating or bonding the layer, which will determine the properties like accuracy, mechanical properties and material properties of the final parts. These also will be determined the cost, time taken for model as well as the amount of post-processing required for it. This chapter will introduce the basic concepts of additive manufacturing and explains AM process from design to application. It also explains about the impact of AM on product development process.